Hello, this is Mrs. Sullivan. Today we're going to be working with section 3.7. We're going to talk about something called direct variation, which is a very fancy term. I know it's very fancy. The definition of direct variation is that it means that the ratio of one quantity to another is a constant or the same. You've already learned that proportional relationships have the same cross products, so you should remember what proportional means. So direct variation is just another way of saying proportional relationship. So just in case you didn't catch that, proportional and direct variation mean the exact same thing. So far, you've learned to identify proportional relationships from pairs of ratios. Remember, our favorite way to do this is cross products. You might like to use mental math, but I like to use the cross products. So if you look at this pair of ratios, look at our cross products. 3 times 20 makes 60. 4 times 15 also makes 60. So yes, these two are proportional. Over here, 3 times 9 is 27. 4 times 6 is 24. Okay, just a refresher. You guys did awesome with that stuff, so we're pretty certain that you're going to do awesome with this. In this lesson, you'll learn how to tell if a table, graph, and equation show direct variation or have a proportional relationship. So let's look at this first example, identifying direct variation from a table. So you might remember that in lesson 3.4, we set up proportions from a table. You can use that information to help you identify direct variation from a table. So here's our first example. One of Mrs. Trombley and I's favorite characters, our good friend Buffy. She's a student we had years ago. Very funny girl, Buffy. Buffy saves $10 per week. She's saving to get her hair extensions. So if she's saving $10 per week and she's just started saving, she's just made this decision, so after 0 weeks, Buffy has no money. After a week, how much would she have? You're right, $10. And then after 2 weeks, $20. Notice that all you're doing is adding $10 a week or taking the number of weeks multiplied by how much she's making. So she'd have $30 after 3 weeks and $40 after 4 weeks. So Buffy's twin brother Bifford, we like to call him Biff, he already has $50 in his bank account, and he's also going to then save $10 a week. So this is where Biff's situation is a little bit different than Buffy's. At 0 weeks, Buffy had 0 money, but Biff is starting out with this $50. So after 0 weeks, he's got $50. But is he getting $50 every week? No, he's getting $10 every week after that. So he starts with 50. After 1 week, we can add 10 more dollars. So 50 plus 10 is 60. And then just continue adding $10 a week after that. So $80, $90. All right. So let's say you were given these data tables and you were asked by your teacher, do these data tables show direct variation, which remember is another fancy word for proportional. So when you were given 2 ratios and asked to decide if they were proportional or not, most of you just picked cross products as your favorite method to be able to choose. So if we look at Buffy's data table, remember you guys were taught how to set up a proportion from a data table. So let's just kind of pretend we've got 1/10 and 2/20, and we want to decide if those two are proportional. We could use our cross products. What's 1 times 20? You're right, it's 20. What's 10 times 2? Again, 20. So it appears that Buffy's information represents a proportional relationship. But if you look at Biff's, what's 1 times 70? That's 70. Is 60 times 2 equal to 70? No, it's not. That's 120. So use what you know about cross products to determine from a data table whether or not a relationship is proportional or shows direct variation. So the first example, or the first reason for how we can identify from a data table would be that cross products are equal. there's two other things that Mrs. Trombley and I would like you to notice about these. Look at the very first column of each of their data tables. Notice that when Buffy hadn't put in any work, she didn't earn any money. But for Biff, after 0 weeks of work, he already had $50. You can tell that a data table shows a proportional or direct variation relationship because when the X amount is 0, the Y amount will also be 0. When X is 0, Y is 0. One more thing that we would like you to notice, so I'm going to squeeze that in over here. If you look at Buffy's, remember when you were asked back in elementary school or sometime earlier this year, if we said, okay, give me a fraction that's equivalent to 1/10. Do you remember what you would do? Well, remember that you would take the top and bottom and multiply them by like the same number. So let's say I wanted to take 1/10 and double it. So I would double the numerator and get 2, and then I double the denominator and get 20. Or I could take the numerator and multiply it by 4 and get 4, and I could take my denominator and multiply it by 4 and get 40. But look at what would happen if you tried to do that with Biff's information. If I take the numerator 1 and double it, I get 2. But again, when I take 60 and double it, is that equal to 70? No, it's not. That would be 120. So if you can't double the numerator and the denominator and get an equivalent fraction, then those relationships are not showing direct variation. So the way I guess I'm going to word that is when X, squeeze that in over here, when X doubles or triples or quadruples or quintuples, but I'm not going to write all that. When X doubles, so does Y. And I suspect we might be needing to clarify that a little more for you tomorrow, and we will. But here's a couple of examples for us. So here we have two data tables. First thing I notice when I look at a data table, I always look to see when X is 0. So if you notice here, I don't see X is 0. I see Y is 0. One of the ways that we can determine if our data table shows direct variation is that X and Y will be 0 at the same time. And so you'll notice that here, they're not. So that's my first clue that this is not direct variation. Let's look at cross products. What's 1 times 2? Well, that makes 2. What's 0 times 2? Well, that makes 0. So our cross products are not equal. And then look and see what happens when I double the X. Do I also double the Y? 0 times 2 is still 0. So that didn't work. So this is an example of a situation that is not direct variation. Look at the next example. First thing I notice, 0, 0. When X is 0, Y is 0, that's my first clue that this is direct variation. Look at your cross products. 0 times 1, 0 times 3. Or if you don't want to use the zeros, 3 times 2 is 6. 1 times 6 is 6. Also look and see what happens when I double my X. If I double X from 3 to 6, do I also double my Y? I did. 1 doubled makes 2. So here's an example of a situation that does show direct variation because it met all 3 of these requirements. And just by the way, if one of these doesn't work, none of them are going to work.